So I'm Alicia Detelich. I am the metadata archivist and manuscripts and archives at Yale. And I'm going to talk a little bit today about using MySQL to run reports in ArchivesSpace. So before I get started, I want to talk a little bit about the benefits of using SQL. You can query across repositories or limit by repository if desired. You can filter results pretty robustly. You can apply conditions to your queries, group, sort, and basically answer all kinds of really complex and varied questions about your collections data. So it's a really flexible and robust query language. One of the most interesting benefits of using MySQL, I think, that people will sort of start to see the benefit of as they adopt the new releases is the enhancements to the reports module in the newest release allows users to add their own raw SQL to ArchivesSpace. This is very interesting, and let me show you an example. So in the previous versions, in the previous versions, you basically had your queries in Ruby code, and so you had to know some Ruby to write them. And I mean, it's not terribly complex, but you do have to know Ruby to do it. And so the new reporting module, which is totally refactored, as you may have seen in the webinar, actually uses raw SQL. So you can see that here, this is actually an SQL query, and it's wrapped in a little bit of Ruby code, but it's really pretty accessible. And so this is the same report, but this is now in SQL. And so this is one that I wrote recently and added to ArchivesSpace just as kind of a test. And one of the cool things about it is that, can you see that all right? So this is one that I added here. And then you can see in the ArchivesSpace directory, I just basically added this here with a translation for the title and a description of the report. And so you can see here, look here, this is the report that I added. You can run it directly in the interface, and very exciting. And then you can get your data. It might take a minute, but basically now you can actually add your own queries to the interface. And so if you just have one person who knows a little bit of SQL, you can actually have everyone in your department run these reports. And so that could be really, really exciting and make it really much more useful to know this kind of stuff. So let's see. Although, I mean, while there are a lot of benefits to using MySQL, there are also some barriers to entry that you might have to get over. So the biggest ones would be not actually being able to get access to your database or not being able to install MySQL clients to run these queries. You know, some IT departments are a little bit stingy about providing access to things. So that's definitely a barrier that you may need to overcome in order to do this. And it does require some technical knowledge. You can get a lot of information out of the database with just a small amount of information about SQL, but learning does still take time, and we don't have a lot of time, you know. And also, to really get the benefit of using these reports and reporting with MySQL, your reports are really only as good as the data that you have in your system. If you have inconsistent field usage or lack of field usage, things like that, you're not going to be able to get as much out of this as you might want to. But data cleanup and enhancement does take time, and so that's an investment that you're going to have to make to really take full advantage of the reporting capabilities of MySQL. And then if you're, yes?
Question on, with the MySQL client, do you need that to design the query or also to run the query?
Typically,
if you put the query into the user interface, do you still need MySQL on your desktop?
No. So if you can write the query in any kind of text editor. Running the queries, mostly I use MySQL clients like SQL Pro or Workbench to run queries. A big benefit of the improvements to the reports module is that you don't have to do that. You can, it will take some coordination with whoever manages the application to actually get the reports uploaded into the application directory, but you won't need a MySQL client in order to run them because it will happen inside the application itself. But for the most part, I mean, until you implement the newest version, you'll have to actually run the queries, you'll need a client like Workbench or SQL Pro. One final barrier would be the fact that you can't really limit access to the database by repository. So if you have 10 repositories and you're all in the same database, and you have some data that you don't want, you can't have shared data, not everyone can see all of your data, then this might be an issue for you if you have some security issues. All right. So to get started, to actually log in to connect to the database, you're going to need this information. So you'll need your database username, password, your host name, your port, and the database name, and then a client to actually enter this information into. So for example, let me get rid of this. For example, oh, that's my dog in a backpack. He actually really likes it. So here is SQL Pro. So I have my local database here. The host name is this, my username, the password, the database name, and the port. And so you just connect like that and connect it to the database. And then you'll get, if you don't do it right, you'll get an error message of some kind. Let's see. Sorry about that. Tabs. All right. So there we go. And then in addition to access to the database and a client, you are going to need a basic understanding of relational databases and SQL. There are lots and lots of ways to get this information. There's lots of online resources, books, Stack Overflow to answer specific questions that you have. So there's a lot out there that you can use to kind of get at least a basic understanding of SQL. And you also need a basic knowledge of the ArchivesSpace database table relationships. And there's some documentation. You can also get some of this information through client table explorers and other sort of tools within clients themselves. Then also always looking at other people's work is really helpful, and trial and error. There are a lot of reasons why you would probably only want to have read-only access to your database. Most of the time, you're not going to want to make updates through the database itself. It's possible to update a lot of records, make mistakes, and update a lot of records within seconds, and it's really hard to go back once you do that. And there are some sort of relationships that may affect. So if you update data in one table, it may have unintended consequences for what happens to the data in other tables. So read-only access is preferred, especially if you're going to have sort of multiple people sort of querying these databases. And so that's why experimentation is useful, especially if you have a read-only database, because then you can just try things, but you can't accidentally update things. So actually, I wanted to get a sense real quick of how many people are familiar with relational databases, the relational database model. Show of hands. Perfect. I won't have to talk too much about that then. And so how about the ArchivesSpace database? Have many of you used this before? Okay, excellent. Let's see. And what about just sort of SQL queries in general? Have you experience writing them, using them? Okay. Awesome. All right. So as most of you know, so the relational database model organizes data into one or more tables, and each table is an entity represents an entity type. So an archival object is an entity in the database, a resource, an extent, a date, an instance, every subrecord. There are something like 90, 100 something tables in the ArchivesSpace database, and that changes depending on the version. As new features are added frequently, those get database tables as well. So the assessment module has, I think, 5 database tables attached to it. And so in each table, there's so each row in each table represents an instance of whatever that entity type is, and each row gets a primary key, a unique identifier assigned to it. And then the tables are linked to one another by adding columns to each table, which hold the primary keys of other tables which are called foreign keys. And so that's how the linking happens. And then queries are formulated by combining the tables, using those keys as match points, and then in addition to that, you can apply filters, conditions, and perform all kinds of other operations. So here is a really, really blurry part of the ArchivesSpace entity relationship diagram. And you can see that there are sort of these little highlights here are foreign keys that are links to other tables, essentially. And so you have an archival object. There, it's linked to a resource, repository tables, enumeration values, which I'll talk about in a minute, and so on. And there's a lot more like this. Yes?
Which tool did you use to generate that?
So actually, Laney did that. Okay. It's for version 2.1.0, and it is a workbench file. So you actually can't open it in a different editor. You have to open it in MySQL Workbench, okay, which is a free program. All right, so SQL, I'll probably go through this pretty quickly also. So SQL, it's a really robust query language, but it's really possible to construct useful and really in-depth queries with a pretty limited knowledge of the language. And the most basic command is going to be the select statement. It retrieves data from one or more database tables, and you basically use this syntax. So select from, and that little star there is select all. So that basically gives you all the columns in the table. And then if you want just some, then you can select column 1, column 2, so on. And I will show you a few basic queries here. So for instance, selecting all. Can you see that? Oh, good. So selecting all from the archival object table gives you all of these columns. So that's kind of a lot. But if you want to just select a couple, so if you want to see the ID and the title, and I limited these to 10,000 records just because we have like 2 million archival objects in our database, and it's a bit slow. So you can get just the archival object ID and just the title if you want. And there's another kind of fun thing you can do. So there's lots of other like little functions and things that make it a little more interesting to use. So this concat here will add a string, and then you can formulate URIs. So a lot of times I use queries from the database to sort of prepare data for updates via the API, and to have the URLs and URIs available makes that process a lot simpler and allows you to work and reuse the data that you extract from the database to make changes. So what's that? Let's see. Those are just sort of simple selecting columns from a single table. And so another... And so once you get, most of the time you're going to want to select table columns from more than one table. That's kind of the benefit of the relational database. And you do that by joining tables through join syntax. And there are four major types of joins: inner, left, right, and outer. Most commonly, you're going to use the inner join and the left join. And so basically, the left join retrieves all rows from the left table, which kind of seems weird, but it's the one that's selected. If you do a left join, it's going to use the table that you select from, and it's going to get all of those rows and then all matching rows plus any null values from your other table. And the syntax is basically like this. So join your table, join this new table. So you say select all from table 1. Then you join table 2 on the primary key ID of table 1 and then the foreign key of table 2. So I can show you, because that is a little hard to explain, obviously. So for instance, if you want to, I'm just going to skip that one. So this one here, if you want to get archival object records that have dates attached to them, so you can, and also, so just a note here, the AO, you can assign aliases to your statements, and it kind of enables you to shorten the queries a little bit. So it'd be difficult to write out archival object every single time you want to query something. So you can basically abbreviate it. And then once you start adding tables from or columns from different tables, you have to indicate which table you're getting it from. So archival object ID, archival object title, date, begin, end, expression, and so on. And so you take it from the archival object table, and then I'm going to join the date on the archival object ID. I'm going to limit this again. And so here you go. You have the same archival objects that are getting returned, but now they have their dates attached here. And so to get a sense of the differences between left joins and joins, so if I hadn't limited this, it would have retrieved something like 2 million. It would have retrieved every archival object and then all of the dates plus any null dates, so dates that didn't have any archival object that didn't have a date attached. But if you do just a regular join, it's only going to retrieve archival objects that have date records. So let's see how long this takes. Oh, actually didn't. It might take a minute. So 1,605,000. So we have about 1 million archival objects which don't have dates attached. All right. And so to kind of show you a few other things here. Let's see. And if you want to select from your date field first and then join a resource record on it. So this will only retrieve 12,105 records because that's the number of resource records that we have in the system. Another one. And then you get the same here even when you pull from the resource field first. All right. Okay. So, and there are also, in addition to the basic select and join syntax, I'm not going to show these right now. You'll see them in a little bit. We have where, having, and, or like, various filtering things that you can apply conditions to your data, to your queries, and then you can group your queries by certain function results, and I'll show you that one probably first. And then you can also order your results by whatever condition you want, whatever column you want. So sometimes you want it ordered by the URI or alphabetically or however you want. So, and here is an illustration of joins because they're kind of difficult to conceive of. So if you have an inner join here, here's your table with this match and this match, but it won't include C. And then here, you'll have your null value here, but there's no match for this one. The left table doesn't have a match, so you end up with this. And then you don't use right joins or full joins too much. Left joins are good if you think you might have some null values in your data. A lot of times I start my queries using a lot of extra left joins, just in case. I don't know if that's like really the right thing to do, but that's what's worked for me. So yeah, and then there are lots of other functions. Concat I mentioned, where you can add sort of string values to create URLs. Cast will change the format of your data. So notes in the database are stored as blobs, binary large objects, and so you need to convert them to text to actually be able to see them. And so cast is a good function for doing that. And so there are a lot more that I won't mention. You can check out the MySQL documentation if you're interested in learning more about that. The ArchivesSpace database can be kind of nebulous. It can be difficult to figure out because there's not a ton of documentation, but this is really improving. So recently there's been a data dictionary that was created. Let me see if I can pull it up. Actually, I don't have an internet connection, but I opened this last night. So this actually lists all of the tables and the columns and then descriptions and example data for each one. This is really useful for figuring out sort of what columns are in each table. And then, of course, there is the entity relationship diagram that I showed you a bit of earlier. It's kind of difficult to navigate. You need like a really big screen to actually make a ton of sense. But it's interactive too, so you can see what your columns are, your table references, and so on. Another thing that I really like to use are the table explorers themselves. So in the MySQL clients. So here, for instance, is a table explorer of the structure of the extent table. And so you'll see here you have all your columns listed. And something I want to mention too, so the way that extents and other subrecords are linked to their resources, their archival objects, resources, etc., are through these foreign keys. So if you query this table, you're going to get every single extent. But then you can limit by, you can join and then get by, you can join an archival object table, etc., on these keys that are in this table, and then we'll get your combined tables. In any case, so another thing here, the relation, oh shoot, where'd it go? So here you can see that sort of enumerated. So the you have your structure, and then you actually use your relations to see what keys you can join to this table. So that's pretty neat. That's that. Let's see. So there are several different ways to learn about the structure of the ArchivesSpace database, in addition to just kind of trying things out. Oh, one more that I wanted to show you. There is a query that I put together that actually queries the database for information about itself. And so this basically looks for data about the ArchivesSpace table schema. So here you can get all your table names, your column names, and then various things about them. So like what kind of data goes in it, if you can have null values, what column number it is, what position it has, and then some of the keys that are related to it. So lots of ways to kind of explore the tables, and that's really kind of the way to get at some of this information. So let's see. And so I'm going to kind of skip over some of this stuff because I'm sort of low on time. But basically, like, these are all the entity types and tables that are in the database. And I think a couple that I want to mention specifically are these controlled value terms and the relationship tables. So controlled value terms in the ArchivesSpace database are stored in the enumeration value table. And so a lot of the level, so ArchivesSpace level, so like series, subseries, file, etc., and extent types and various other sort of controlled lists that you have in the database are stored in this table, and then you join them to the tables that you are querying to actually get those in a text form. So they're stored as numbers in a table, and then you join the enumeration value table to it, and then you can see the actual text value. And I will show you this in a minute here. And then the relationship tables basically only contain keys. They are used specifically to link tables to one another. So they'll have like 2 keys basically, and then you can use those just as sort of a way to link tables. You don't actually display data from those. Those will want. Okay, so now I'll move on to the actual queries here. Never mind. So again, I am not connected to the internet, but this is from yesterday. So I have a GitHub page here, which is available to you all after this is done. I'm not going to show you every query. I'm going to show you sort of a couple from each one to get you some sense of how each of these work. And so the first use case that I kind of put together, and a lot of these I actually wrote as part of my day-to-day work. And so it does have application. And I think a lot of these you can actually test out on your own data it should be pretty applicable or pretty universal. So the first use case is column count. So a lot of times we want to know like how many of different types of things we have. So like how many of each extent type do we have, or like how many of our materials have the processing status of completed or in process, and so on and so forth. How many agents are linked to a resource record? So it's pretty easy with just something like 5, 10, 15 lines of SQL to get all of this information. So one example I can show you. So let's see, what we want to get a count of extent types. So you're going to select, so this is the enumeration value table that I was talking about here. And then you use the count function to actually get the counts. And so this is the basic structure of sort of a count query. And it requires the group by to actually get this as a list, and then it'll give you the count for each one. You take it from the extent table, and then you join the enumeration value table in order to get a text representation of the extent type. So you run this, and you see that we have 22,000 folders, 21,747 linear feet, and so on. So you can really get a sense of what extent types are in use in your database and how much of each one you have. So another example of this, similar, would be how many archival objects do we have in each language? And so run this, we have 5,000 or so in English, a lot in Greek, surprisingly. And again, this is really only as good as your data. So if you don't have, I think language is conditionally required, I think, but I think you can go without it. So it really depends if this, the accuracy of this depends on how much data you actually have in your database. And then, say you want to know how many of your collections are in process, and they all kind of use the same structure. You might add another table depending on what you're looking for. But there we go. So we have 8,000 completed accession records, 19 unprocessed, and then various new ones and things like that. So you can really get a good sense, a good overall sense of the kinds of things you have and how much. So one more thing that I actually used recently, we just did a huge authority reconciliation project, and we wanted to know if the number of linked agents that we had in ArchivesSpace matched the number of linked agents that we had in our Voyager database. And so we did this comparison to identify how many agents were attached to each resource record. And so this collection has 554. Don't get me started on that. But so it gives you can actually, it does have practical benefit. We use this to verify that our mass authority import had been successful. So there are practical reasons to use this kind of stuff. So yeah, you can do that with, basically anything that you have numbers of, more than one thing of, you can get counts. And so moving on, another use for SQL is getting inventories or getting data about particular collections. So, for instance, you want maybe to get a box list for a particular collection. You can do that. You can get a distinct box list for a collection with just a few lines here. And these relationship tables that I told you about basically link the subcontainer table with the top container table. And it's just a bunch of foreign keys, and they all link together. So you run this, and look, we get all of the boxes for this particular collection. Yes, we have 5 box ones. It's fine. So yeah, and so we use this with the barcodes and things to sort of track our shipments and our transfers from offsite storage. And so it's useful to have these kinds of box lists to know where things are going and what their barcodes are and so on. Sometimes, though, you want to know like what you want to get an inventory of like a box and folder list, for instance. So you want descriptive data that's connected to a physical thing. So you can use this. This is a little bit more complicated, and it involves a few relationship tables. But the nice thing about the sort of the physical control stuff is that you can use this basic template, make some slight modifications to the tables that you use, and you can use this for a bunch of different purposes. Like you can, it all depends on what the kind of thing that you want to return. So for instance, so I queried this here, and we have 2 instances that are associated with each archival object. So we have the microfilm copy of it and then the actual physical copy of it. And so this query will return all of that. And so you'll see there are duplicate archival objects in there because each one has 2 instances. So that's the kind of data you'll get for there. But then you want to do something like something else. Let me see if this is actually one. You'll get, in addition to, you'll get sort of folder numbers as well. I don't know if you can see that. Yeah. So that's a box and folder list. Very exciting. And then one of the last things you can do to get sort of inventories of your collection is just all components. And so this here will include, this will only include components. So you just get one list of descriptive materials, descriptions of materials. And it won't include any duplicates because it doesn't have any location information attached. Or physical storage information. So the nice thing about this too, so we attach all of our instances, all of our box folder information to archival objects. So those previous queries won't return any information about series. So this basically includes everything. So this is mostly to get descriptive information. Okay. So moving along, because I only got a couple more minutes. So sometimes you want to get information about all certain types of things. So this is one way to do that. So you can get, sometimes you want information about all the dates in your database. So we did a huge normalization project on our dates as part of our PY implementation. And this is what I use to kind of get a report of all our dates, make some modifications, and then upload that data to the database. And so this here will get you all data that's attached to an archival object in your database. And again, this is like a huge number of records. But a really fun thing that you can do is use this to filter your data. So I want all dates that begin in 1950 and end in 1955. And there you can get that. And that's pretty great, both for your own usage, and it's useful in helping researchers find things from a particular date. And then also you can use it to identify cleanup needs. So for instance, this will find dates that have an expression, but it doesn't have anything in the begin and end date field. So you can use this to identify cleanup needs. Have unstructured dates. You can use this to identify dates that need structure. And then you can do a similar thing with extents, which I have here. And then you can also find things like, I want all page boxes. So look, same kind of similar join structure as the previous, like box lists and things like that. But then you add a couple of filters, and then you can find everything that you have in the same kind of box, which is really useful for collection control. All right. Really running out of time. Give me 2 more minutes. I can show you a couple more things. So there are also situations where you're going to want to know things about sort of time and location based data. So I want to know, for instance, when the most recently modified archival object records. So you can keep track of how much work has been done in your database. So this will order all of your records by the modification date most recently, archival object records specifically, although the resources are joined. Interestingly, if you modify a resource record, it will, never mind. If you modify an archival object record, it will not change the modification date of your collection level record. So sometimes the resource modified dates are a little bit misleading because you went into a record, you modified it, but it doesn't show up on the resource record modification date. It's going to show up in the archival object modification date, but it can be just a little bit of a gotcha there. So that's fun. And then you can find, for instance, all your new accessions. So if you want to find every accession that you had in 2016, you can find that. And that's pretty nice because then you can get a sense of your rate of acquisition, how much material you took in a given year. And then you can do things like get a sense of when your restrictions are about to expire also. So I joined the rights restriction table, which has structured restriction end dates, and limited it to everything that ends after 2016 that is an access restriction. And there you get a list of restrictions that will eventually come up for review. And you can do this for archival objects as well. Right. So, and then you can also get, let me show you one more thing. So you can get all your locations in a given room. So I want to know everything that's in this room. And so this is a query you can write to actually get that information. And so you get a sense of what's in what location, is that what's supposed to be there, et cetera, et cetera. And then finally, linked records, like I said, are kind of weird. Here, I'll show you the other one. In that they require relationship tables to make them work. So you join the subject relationship. So you have your subject table, you have your resource table. You need to use the subject relationship table to actually bring those two together. There's no foreign key in either one of those that directly meets with the other one. So that's where the subject relationship table comes in, because it's just keys that sort of meet up with those. So that's how you link the subjects with their linked resources. So you run this here, and then you get your subjects or your resources, and then the subjects that are attached to each resource. That's pretty exciting also. The only trick here is it works a little bit different with linked agents, because the names table, so there are two tables that it gets a little confusing. So there are two tables that deal with agents. And so you have the agents themselves, which have one record for each agent. But then you have a names table. And that names table includes all variant forms of names, so that when you join it to the agent table, if there's a bunch of different names associated with one agent, you're going to get duplicate agent records, which, depending on what you want to do, can be a little bit challenging. So here, I didn't actually include the names because you'd get multiple of the same agent attached to each one. So it's something to be aware of if you want to query your agent tables. And so basically, all of this is to say, it's a very short demo, all of this is to say that learning MySQL can have a bunch of benefits for advocating for your collections. So if you can show, that you've taken in this much material, that you've processed this much material, you can really demonstrate your value to administrators and things like that. And you can use this data to create visualizations that can help do that for people that don't want to look at these huge, ridiculous reports. There are ways to kind of summarize these things and make them more digestible for administrators. It's also vital for collections management and physical control. I mean, we use the results of these queries for all kinds of sort of administrative tasks within the department. And then also, maybe most importantly for me, just because it's my job, data auditing and data updating is so much easier when you use queries to extract the data. So using the API to get information out is a little trickier than using SQL. SQL is a lot faster, and there's all kinds of crazy combinations that you can do to get data. And so for me, this is the most important, and to be able to think about how you can structure your queries and your outputs so that you can easily manipulate them and then use them as inputs for mass update is a huge benefit. So sorry, this is a little quick or long, depending on who you ask. So I'm here for questions if you want them.
So can you take the information, like I need a report that counts all the boxes and everything, because I need to give this total volume we have.
Mm-hmm.
Right now I'm using an Access database, so I have record storage boxes, this box.
So how many boxes, how many of each type of box you have, or total volume? So there is an extent calculator within the interface that may do that, but that's presuming that you have top container data in there. The short answer is yes, you can get total volume by querying the top container databases, or the top container tables.
So you showed us some splendid reports. How do we then take that information and generate a nice data visualization for, say, our administrators?
So there are free and paid software programs that can help you do that. There's also, it depends on your technological skill. I mean, there are Python libraries that you can use for data visualization. That is a much higher barrier. But something like Tableau Public, which is free, although you do have to share that data publicly. So Tableau can be expensive if you want a private license. But there are all kinds of varying degrees of paid and free software that
There is a way to export it.
yeah, so with Tableau, you can actually connect your database directly, but all of these queries are exportable in CSV form. So yes, so basically everything here can be exported as a CSV file, and then you can use that to create all kinds of tables, visualizations. You can do it in Excel if you want. And you can also, a lot of the times you can export it in all different formats too, JSON, XML, whatever you prefer.